Okay, we have solved for missing sides in this lesson. Now we need to try something else. We need to learn how to solve for angles. But before we get started, we're going to take a look at the sine function. You've had sine. We've used it now a few times. And sine is a function that takes degrees. Just think of it as a machine. It's a machine that takes in degrees and it spits out ratios. Equals a ratio. So what I want you to do is take a second, go down this list, grab your calculator and just go down the list. Sine 45 equals, and then put the decimal in here. We could even go to 3 decimal places. Put sine 30 in, put it in there. Take a second. Stop the recording. Try this on your own. Okay, so hopefully you got these numbers right here. I put a couple extra decimals on this one. This one didn't need the decimals because it works out perfectly to be a half. So, if you put in an angle into sine, it spits back a ratio. Put in an angle, it gives you a ratio. These are all the ratios. You might recognize this ratio from our 30, 60, 90 chapter, that if you have the short leg over the hypotenuse, that would always be 5, and then that's what the sine ratio is, short leg over hypotenuse. Now, let's think about this. Sometimes we're going to need a machine that doesn't eat degrees and spit out ratios. We need a machine that does the opposite of that. We need to feed it a ratio, and we need it to give us the degrees. So what we're looking for is the inverse of sine. Does the opposite. For instance, we've been going from degree to ratio. We want ratio back to degree. Here's what it looks like. It's almost the exact same button on your calculator. We'll go pink this time. And what it is it's going to be sine of our ratio is equal to our degrees. Give me a second to clean this up because that's way too big. Shrink it down a little bit. Sine of the ratio is equal to the degree. So we're going to be taking our ratio number and putting it in there, except for we can't use the same machine. They're not the same thing. So here's what we have to have. There's a little inverse sign right there. The little -1. It's the reverse of sine. Look on your calculator. Do you have that button? Some of you might have to hit Shift, Sign, and with the -1 there. If you click Shift and the same sign button, that might give it to you. It's going to look something like this. Sine, inverse 1, and now here's the thing. You have to put parentheses this time. 1, you can write it as a fraction, or you can use a division symbol. 1 divided by 4 is approximately equal to, let's grab a calculator, Shift, Sine, parenthesis 1 divided by 4 equals 14.47. So I'm just going to say 14.5 degrees. Okay, let's stop real quick. Stop the recording. Try these on your own. Okay, did you get 60.5 degrees and 36.3 degrees? That's what you should have. There is an assignment in your CUDA that looks just like this. Take a look at these problems here. This one right here, just like we've been doing, sine of an angle equals a ratio. And you've got to use the inverse sine to solve these ones right here. And there's an inverse cosine, and there's an inverse tangent. So right now what I would do is I would stop this video and I would just do these 8 problems right here. It's just calculator work. It's getting you used to using the calculator. Okay, moving on. Inverse tangent. That's what we're solving for here. You need to be able to use it. So let's see. Where's our smiley face going to be on this problem? We say tan of angle Z. So let's see. Tan of angle A. So we're talking about angle A. That's what we're using. And tangent uses what? Opposite and adjacent. So when we go to set up our ratio, it looks like tangent of angle A is equal to, and it's going to be, who's on top? Let's see, you've got Z over 1. But now you can turn this using inverse tangent. It's going to look like tan, I'll put a space in there and fix that in a second, Z divided by 1 is equal to angle A. And this, when you put it in the calculator, will have a little -1 right there. So it's all the ratio moves to the inside the machine, and the A is the answer. It's solving for an angle. We use these to solve for angles. And there's a sine and a cosine and all that good stuff. So use a calculator to approximate the measure of angle A to the nearest tenth of a degree. So don't even think about what we just did. Go back to your original trig setup. Can you set this one up using trig? Well, smiley face, what angle do we care about? We care about angle A. That's our location. And we see that, oh, we have an 8 and we have a 10. What ratio is that going to use? It's the opposite and the adjacent. So it looks like we're using a tan ratio. Come over here. Tangent of what angle? It's angle A. Is equal to our fraction bar. And on top of our fraction, we are going to have opposite, 8, over adjacent, 10. So we've got our ratio all set up, but we don't know the angle. That's our question. We don't know the angle. This is where we use our inverse tangent. So I'll just write it like this. We are going to change this now to tan inverse of our ratio will give us our answer. And when I put this into the calculator, you could turn this into a decimal. This is going to be 0.8. You could use that if you wanted to. But I would just say 8 divided by 10. And you need these parentheses. Don't get rid of those parentheses. You've got to have them there. Otherwise, it treats it totally different. Try it both ways. Maybe type this into your calculator just to, you can see what happens. If you do this, 8 divided by 10, this is not going to end the same. That's all I'm going to say. You can try that. It comes out totally different. So you need these parentheses. All right, let's take that. Shift, button, tangent, parenthesis, 8 divided by 10, close parenthesis, equals, I'm getting 38.65, so I'm just going to say 38.7. And this is in degrees, and that's my angle A right there. I could do it again for this triangle. I know this is a 90, or I could also just subtract from 180 if I'm trying to find B. Okay, try this on your own. This is a 90-degree angle. You've got a 2, you've got a 3. See if you can find everything in this picture. So I'm going to want to know, maybe smiley face is angle A, heart will be angle B, and then when you're all done with that, can you find angle C? And there are a lot of side C. There's a lot of ways to solve this problem, but one of the IXLs is going to be asking you to find multiple things about these problems. So take a second, stop the recording, try it on your own, then come back and check and see if you set it up correctly. Okay, here we go. I got some of it set up. When we set up our ratio with our smiley face at angle A, opposite is 2, adjacent is 3, and then we use inverse tan, and it turned out this angle is 33.7. Well, does it make sense? Yeah, I kind of look at it. Okay, 2 is the smallest side. The angle A is going to be the smallest angle. Similarly, up here, we used the angle B perspective, and we said, well, it's tangent. It's opposite over adjacent. So really, these numbers just switch. We just switched angles. Type this into my calculator using inverse tangent, and I got that this heart angle, angle B, is 56.3. All right, I'm trusting it. Yeah, it makes sense. This angle's a little bigger since 3 is a little bigger than 2, but here's how you really know you did it right. What do these two add up to be? If they add up to be 90, you know you did something right. Yeah, that's a good thing. Works out to be 90. If you want to know C, you could do almost anything you wanted. You could do a Pythagorean theorem to get C. You could try a cosine relationship on the smiley face. You could do a cosine relationship from the heart. You could do a sine relationship from the smiley face or a sine relationship from the heart. That's 5 ways that you could find C. I just want you to pick one of them and solve it. I'm going to go with sine personally because sine's my favorite, and I'm going to use smiley face. So we'll say sine of A is equal to, let's see, sine is opposite, so that is my 2 over my 3, except, oh no, it's not 2 over 3, sorry, 2 over C, undo. It's 2 over C, except I don't put A here anymore because I have A right in there. So I'm going to go back and I'm going to edit that. It's not A anymore. It's now 33.7. Enter. Backspace. Click. Make it look good again. I can now solve this for C like we did in the last video. Cross, multiply, divide. 2 times 1 divided by sine. So I'm going to put that in the calculator. 2 divided by sine 33.7 equals 3.6. 3.6. There's my answer right there. That's a decimal. Okay, let's keep going. Only got a little more time. If A is an acute angle, use the calculator to approximate the measure of A to the nearest tenth of a degree. So go ahead and try these. You're going to notice some funny things happen. Just play with it. You're not going to be quizzed on any of this or anything. I just want you to notice what happens when the tan ratio is tiny, what happens when the tan ratio is bigger than 1, and what happens when it's even bigger than that. This is just for you to play with. Go ahead. We've basically done these already. Just like tangent has an inverse, cosine is also an inverse. Find the measures of acute angles. Use your calculator to approximate. We've done this already. I know you can just type these into your calculator and do them now. Inverse sine, inverse cosine. Turns out angle A is 33.3 and cosine A is 61.3. Just calculator problems. Let's keep going. Here's something not in your notes. A little check-in. You need to be able to solve all types of these problems. First off, can you pick an angle and put a smiley face there? Then, can you pick a ratio? And I'm going to tell you what this SOHCAHTOA thing is pretty soon. Can you pick a ratio to use? Is it sine, cosine, or tangent? Can you set up a ratio? Can you put everything where it goes? And then there's 3 kinds of problem. Solve for a missing side when it's on top. Okay, here are some setups on this page. This one, opposite over adjacent. Yep. All right. Stop the recording real quick. Try these on your own. All right, here are the setups and here are the answers. These are the 3 kinds of problems.